Hey guys, it's Keshima92 here. I just recorded a video on game architecture and game objects and the game object hierarchy, and how if you've ever tried to program with Unity, they use these entities or whatnot to kind of try to make sense of the game world. I'm going to go over how to do that, maybe programming it yourself in C++. Last video kind of went through me kind of organically typing it out and going through it. But this video here will be hopefully a lot more quicker for those of you who don't want to spend an hour and 20 minutes or an hour and a half watching me program and talk about the code. I will still talk about the code in this video, but it'll be a lot quicker because I'm just going to go over the important parts and explain while I'm typing exactly what things do. I'm going to be using Visual Studio 2017, which can be a console application, and we're just going to call this Game Architecture. I'm going to call this an episode. I'm going to call this episode 1. It's not really relevant. Yeah, I'm going to save that. This is the stuff from the last video. Anyways, we're okay with all this stuff here. I'm not going to be creating new files. I'm just going to be adding it all into the same thing. But pretty much what we want to do is we want to have some sort of game object. And we want to have it, some super game object, some like master object that kind of we attach smaller objects to. We want to do something like this. Where we have the hello object, and we want to set a parent of it, meaning that the hello object's parameters are influenced by the super game object's parameters, or the super game object's properties, not parameters, or attributes, whatever you want to call them. And we want to set the parent to be super game object. And then we want to be able to do something like render object, super game object. And pretty much this is what we want our main code right here to be, and pretty much we want to be able to render information of the super game object onto the screen. And since the super game object has a child of hello object, we also wanted to put that onto the screen. I'm going to keep this code here. Won't really affect what I'm doing, but really we already know we need one thing. We need a game object class. Ooh, I'm shivering. Right. But we don't quite know what goes in here just yet. We do know that our game objects, everything inside our world, has properties to it, so we can call it maybe properties something, but we're going to call it components. We're going to call them object components. So we're going to have our object components. I'm going to call it type. Wait, that's not right. Object component, and we want an array of all the components that we have inside an array here. Yeah, leave that blank for now. We'll get back to that line. I know it's not finished, but since we know we have our object components, we're just gonna have right now we're gonna make an enum of our object component type. We're gonna have In this video, we're going to pretend that we're doing a text adventure. So we're going to have a description component to be able to figure out, have some sort of description of objects in our world, because there's no visual aspect except for text. And we want to keep track of how many object components types there are. So num components. And that's what we want to put here, num components, because we want this to kind of change dynamically as we increase. Let's say we add something else like coordinates or something. Just arbitrary example, then we know that this will be covered. We don't have to change that code later. You go here, object component. We don't have an object component class just yet, so we're going to go class object component. Now we do know that each object component has a type because we've already specified that right here. So we're going to go object component type, that's private, and then we want a public object component. We want to be able to specify the type on construction. There's a reason why we're doing this. It'll be clear later on why we're keeping track of the type of the object that we're working with. And we also want to have a way of retrieving the type from it without violating some wonderful programming practices here. So we're going to go ahead and do object component type get type, just like that. Oops. Of course, with actual proper programming practices, you'd have the functions declared in a separate CPP file, and the contract of the class would be inside a header file. But we're just doing it all in one CPP file for now, so we don't have to worry about running back and forth between files. Just checking over my other window here. So, thing is, we don't have any components. We described a description component here, so we know that this array is at least of size 1, and we haven't actually provided that the object for it yet. So we're going to specify that right now. We're going to do the description object component, and it's going to be inherit the object component class publicly. And we know that we're just going to use strings to hold the description. So we're going to have to include a std string up here. Right? So this is the description of the object that we're working with. Now we do need ways of initializing the object, so we're going to have to build a constructor. And this is where the type comes in. We want to be able to know what kind of object this is without actually having an object of it. That might not make sense right now. It'll become clear when we kind of build on the game object class here. So now the object class description class does now have a type, and it's set up here, right? We also want another constructor, one that takes into account that we actually do have data that we need to set. Pretty sure we can just go like that, and it'll call this function up here. I will do that actually. And then we want description as such object description object. We'll just do that, safest. There we go. Now we also want a way to get from the description object component the data inside of it. So we're just going to do it this way. Get description, return description. We also want a way to set it. We don't really actually need this right now. Usually when I have a get, I usually like to make the set right away, if it's relevant and actually useful. If not, then there's no point of making it. If it's something of a function that you'll never ever use, then you shouldn't really be making it. There we go. So now we're on to our object component here. There's a lot of functionality that we need to program into it, because we have our set parent right here that we need to somehow encapsulate somehow into this whole thing. So first thing we want to know is that if we have parents, that means that they have children, and a game object can only have one parent, but a parent can have multiple children. So to work with this, we're going to actually do a vector of game objects, pointers of course, because we can't reference the object itself inside of itself. And actually we're going to actually include the other things we need right away, such as standard input output, and the algorithms class. Algorithms we are using for the find function. Anyways, we're going to call this children for all the children in the array here, or in the object class, game object class, all the children that it has. And we also know that each game object has a parent, except for the special objects, like the super game object does not have a parent. Wow, apparently I can't type public. There we go. So with each game object, we want to make sure that we have the parent set to null on initialization. And yeah, so we want to be able to add components to objects. That's the whole reason why we added this whole thing, this description object component. It's a component of an object. And we have, in fact, object component right here, an array of them. So we want to be able to add object components to this array. So we'll do that right now with void add component, object component, component. And it's fairly simple. This component, and then we go component dot get type. That's why we needed the type before, so we can reference the memory location in our array with the type, and we say it equals the address of the component. If you're doing it like this kind of, once you have these references set up, you don't really have to, on the outside of it all, you don't really have to be worried about pointers. You just have to understand that the game object class does not manage the pointers for you. You pass it references to objects. Now those references could be references of dereferenced pointers, and the reason why I have it this way is because if you're passing a dereferenced pointer to add component, then it's kind of understood that you as the developer know that you have full control over that pointer and you have to clear that memory address up, not the game object, because the game object understands it just as a reference to a component and not a reference to a dereferenced pointer, if you kind of get where I'm getting here. It's pretty much something, it's kind of like a contract thing where it's saying, hey, this is what I'm expecting. I don't care how you get it, but you should understand that I'm not going to be doing anything extra with it than what you might expect me to do. Right? So, next thing we want to do is be able to retrieve the component. We could easily do things like, description component, and then add a whole method for it. But just to have it generalized and have it so that we don't want to be adding new functions to the game object each time we add an object, a game object component to the code. So we're just going to use a template type name T, and we're going to have it return a reference to T, because we know that all of our objects that the game object holds are valid pointer to objects, because we're only passing those to it, and we have to make sure that we're not passing anything that might become invalid. Anyways, so we get the component this way. And this is kind of a little bit of a tricky part. We want to return a dereferenced pointer of type T, and we get the pointer from the component array, but we use this constructor right here as every single object component has to have a constructor without any parameters that sets the type. This is why we did this, right? And this is why we have this, so that we can use this minimal constructor just to figure out what the type is of this T value right here. Type.get type, like that. And like that, there we go. So we're going to go down. we're going to do another part right here where it's we're going to go on to the parents now. Set parent. These are a little less confusing here, more to do with the vector managing, right? Managing your vector here. Game object, and this is where we use our algorithm include file. We want to find a value in game object, which is we want to see if the parent that we're trying to pass to it has this object already inside its children. If it does not have it inside there, then it should return game object dot children dot end. And if it does, that means that our parent doesn't have the current object in here. So pretty much down here we're saying hello object, and we're saying the parent to super game object. So pretty much we're saying, is hello game object already a child of super game object? If it's not, then we can add it. So we go game object dot children dot push back this, and then we want to set the parent to equal game object. Now there's a part here that I realized I didn't cover in my last video, was that if the object already has a parent, we have to remove it from the other one. So right here we can just go if parent, oops, then remove parent. That's pretty much all we need to do, and then we set the parent. Right here we'll write our remove parent function. This one's pretty easy. If parent, actually, since we're doing if parent here, we really don't need this here. It's redundant. If parent, now we want to get the iterator of the current location of this child inside the children vector. So we want to use the find algorithm again, and we want to pass it the parents children, the first iterator, and the parents the end iterator of the children vector. And we're looking for this again. Then once we find it, if we find it, so in fact we should find it inside the array. If we're doing programming through test-driven development, we would want to check for sure that the parent is not some random pointer, some random object, and actually make sure that's the actual parent of the object or something like that. Anyways, we're going to go ahead and go children.erase the object itself and set the parent to equal 0, not 9, 0. This is important later, as we'll see inside the managing output and drawing stuff. So there's our kind of base game object class. We can add more to it. There is one function we'll have to add just in a bit, but I left it out just for demonstration purpose. So as to why we need it. So we're going to have a render object class. We're going to go game object. Do game object that way. Now we want to check if our game well, we'll actually leave that out for now. It's the demonstration thing. We want to have our description. Description component. A reference to some description component. Call it description component. And we're going to get it from the game object itself. Game object dot get component. And this is the fancy part that I described with the T right there. We can just go like this, and whenever we add a new game object component, we use the same get component function, and we just put the class name between these two angle brackets here. And we would simply just add them by doing the base functionality we'd have to like implement. The requirements we'd have to complete is we'd have to add a new enumerator type in here, and our object component would have to inherit from object component, and it would have to have this base description or base constructor, or else we won't be able to use this constructor here to get the type. They actually retrieve the component from the array inside game object. So here we get the component, and then what we want to do is simply just print out the information, description %s/n, and then description component dot get description dot cstr, convert it to a C string. And here this will render a single object, right? Now one problem we have here is that if we try to do this right now, none of our objects actually have this component to it. So it'll try to retrieve the component. This will return a null pointer. It'll try to dereference a null pointer, and use it for this reference here, which is not good. So how we manage that, we have to add another function up here, pretty much the same as this one, except now it's returns bool. And converts this to a bool type, so it pretty much converts the pointer to a boolean, which is simple enough. In fact, we don't really need this. This is just to suppress compiler warning. Let's make sure I typed that all right. Yeah. So here we go. We have to check first if the game object has component description component. Now if you know for sure that if when you're programming and making a game that your object definitely has a component, then you can go ahead and skip this completely. You don't really need that. That's something's wrong here. Oh, there we go. So now it'll print that out. We're gonna actually do a little demonstration here. We're gonna add our description object components. We call it D1, and we're just gonna go ahead and initialize it to is the super game object. And we're going to go to another one, D2. This is the child object. Call this child object now. So right now, if we actually try to run this program, it won't actually print anything out, because even though we're calling this, we have not actually attached this to the super game object. To do that, we can just go ahead and do super game object dot add component like we showed up there. No angle brackets, we just have to do D1 like that. And now it should, let me change this to 64, compile it. One failed. Let's see what this is. No binary object type. Let's see here. Oh, this. That should be like that. There we go. Now if we run it, it's only going to print out the description of this is the super game object. Even though you've added a child to it, or child object, it's not actually displaying this either yet. So how we have to do that is what we can do is inside our render object, while we're rendering the parent, we just kind of work our way down the tree, because pretty much we've implemented a hierarchy tree. And so what we can do is go right for game object pointer child game object get children. This is why we need the get children class right there. What we want to do now is render the children. We just call the render object class on the children. Dereference the child. There we go. Because it's a pointer, we don't dereference it. And now this should. Oh wait, not yet. We still need to do child object dot add component D2. There we go. Compile it. F5. And now it prints the description. This is the super game object description. This is the child object. Now if we look back at our code, I was pressing any key. I was pressing like enter and it wasn't working. I had to like press space. That was kind of weird. we're not actually calling a render child object down here. We're calling it through this because super game object is the parent of child object. So if we kind of do this F7 and then Control F5, it won't print it out anymore because it's not there. It's not in the hierarchy tree. But if we go ahead and if we do this even not oh wait not that this is a bad example what I was trying to go for. Anyways, so yeah, that's pretty much the whole thing about this game object hierarchy thing. If you have any questions, maybe you can watch the other video that I did on it. It's pretty much the exact same except it's 3 times as long. It's a little more organic, I think, to how I went through the process of trying to figure it out. Although it is something I've done many times, so for me it's just kind of almost like just typing out an essay that I've written maybe like 10 times in my life, right? So it's, yeah, once you understand the concepts, you can kind of get them going all the time. One difference I'd like to point out here is that you can have this function here. Instead of doing this, you can do something like, a quick example is, you can go description component dot render like that, and then in the description component you can specify what happens when you render, which in this case is this. And you don't need to do this get description like this. And it works exactly the same. So you can put your functionality of how your components want to work inside the component classes themselves, or you can take them out from it and implement them somewhere else. So instead of doing this, you can also do something like maybe you can have some other function, some other thing, renderer, like you can call it like the master renderer or something, and you pass the description component, and then maybe that decides based on other information that it may be previously rendered, how it's going to display it. It's really this these game object components things. It's mostly just an approach to this, and you can bend this code to your will. So yeah, thanks for watching. Hope you enjoyed it, especially this way shorter version. Yeah, so thanks for watching. Again, it's Kajima92. Try to keep you posted on things that are going on. Not much right now, but have a nice week.